Hello everyone, my name is Alexander. I am your grade 12 physics teacher. Today's topic is on AC circuit. Our learning objectives: to explain alternating currents, to explain peak and root mean square value of currents and voltage. Let's start the lesson. What is an electric current? Electric current is the flow of electric charge. What that means is that once we have a charge and it starts moving, that constitutes an electric current. The movement of charge is what constitutes an electric current. How do we express electric current mathematically? That is what's the mathematical expression of current. We have the expression here, I is equals to charge all over time. That is, I represent the current, Q, the charge, T, the time. We can also write it in this form. Many of these forms is applicable. Electric current is measured in ampere or amp and can be calculated by finding the total charge, total amount of charge in coulombs, which passes a specific point in a given time t. One thing you have to understand about this equation, we can make a subject formula of it. A current is equals to charge all over time. If you are looking for charge, that means the charge becomes current times time. If you are looking for time, time becomes the charge all over the current. But basically, charge is, when it is in motion, constitute current. Let's look at this simple example to recall the concept of solving a problem. Constant currents. Here we have a charge of 30 coulomb. The charge is given to us, which is 30 coulomb, passes through a 24 ohms resistor. The resistance is given as 24 ohms. In 6 seconds, at the time, duration is 6 seconds. What is the current through the resistor? That is, the current is what is being required. From the basic equation, current is charge all over time. That means 30 divided by 6. 30 divided by 6 will give us a current of 5 ampere. That is the current that flows at that time. Here's another one. The current through a light bulb is 2 ampere. How many coulombs of electric charge pass through the light bulb in 1 minute? We can handle this problem by listing out the data given to us. The current is given, I, which is 2 ampere, and the charge from the question is what we are looking for. The time duration, which is 1 minute. Well, we have to convert this to the SI units. 1 minute is 60 seconds. And remember, current is charge all over time. Then the charge becomes the current times time. Working with the given data, 2 times 60 will give us 120 coulomb. So that's the charge when a current of 2 ampere flow for 1 minute. What is direct current? What is direct current? It is a current that flows steadily or constantly with time. That's direct current. It flows steadily or constantly with time. Here's a graph here that shows what we're trying to say about direct current. You have the magnitude here and the current in this direction. This represents the current flowing steadily with time. What's an alternating current? An alternating current is a current that flows periodically with time. That is, it goes up and down, to and fro, like this graph form, waveform we're seeing here. You can see it's not steady. The graph will compare both of them, direct currents and alternating current. We can see the difference between the two. This is the alternating current that flows periodically with time, and this is direct current that flows steadily with time. But remember, in either alternating currents or direct currents, they still use the basic equation. Current is charge all over time. Current is charge all over time. You understand, class? Now, James, I want you to say something. From the graph, what do you think about currents, alternating currents and direct currents? What do you say? Okay, can hear you. Okay, James, you say direct current flows steadily with time. Okay, that's better. What about you? Paul, alternating currents flow periodically with time. That's correct. Yeah, let's look at some of the basic features that distinguish alternating current from direct current. Yeah, we have this symbol here, IN. We have VM here. And then we have symbol here, W. And then we have T. We all have their meaning. Let's see what each one of them stands for. The I, current, is being expressed in this form. This is the instantaneous current. Is equal to the peak current sine 2 pi frequency times time. Or you can write it in this form. What you need to understand here is this. From that equation there, this is angular frequency, which takes the value of 2 pi frequency. F is the frequency. This is the peak voltage, and this is the peak current. V is the instantaneous voltage, and I is the instantaneous current. So the expression, this is relationship, this expression here, when you have a sine, I is equals to I naught sine WT. This shows the relationship between the instantaneous current and the peak current. Likewise, we can also do the same. Instantaneous voltage is the peak voltage sine WT. The relationship between the instantaneous voltage and the peak voltage. Here we have all listed here. I'll allow you to write this down, just 2 or 3 minutes to put this note down. Remember, I, instantaneous current measured in ampere. Then we have the peak current, also measured in ampere. The frequency, measured in hertz. The time in second. WT, which is the angle. Remember, the symbol here, W, is angular frequency. That's the phase angle of the current of voltage. V is the instantaneous voltage, and V naught is the peak or maximum voltage. There's a relationship between the root mean square current. The root mean square current is an effective value of the alternating current. It's given by this expression here. What we can see from this expression shows that the root mean square current, which is equal to the peak current square root of 2. We can, if you are looking for the peak current, make it a subject of formula, you have the root mean square current multiplied with the square root of 2. If you prefer not to write in this form, you can also express the root mean square current in terms of the value 0.707 I naught. 0.070 I naught. The root mean square current is expressed in this form. So the one way of writing, if you refuse to write in this form, if you don't want to write in this form, you can also put it in this form. That's how can we also, how is the root mean square voltage and peak voltage are related? How are they related? How are they related? We can do this by also using the example of the root mean square current. Remember, the root mean square current is equals to the peak current, the square root of 2. Likewise, we can do the same thing. The root mean square voltage is equal to the peak voltage all over the square root of 2. That's how the root mean square voltage and the peak voltage are related. You understand, James? Paul, any question? Thank you. You quite understand. Yes, a problem. Let's solve this problem here. Yes, the current I in an AC circuit. The current I in an AC circuit is given by the equation I is equals to sine 30, 100 pi t, where t is time in second. Deduce the following from this equation: frequency of the current, the peak value of the current, the root mean square value of the current. Now, let's solve this problem. The expression given to us is I is equal to 30 sine 100 pi t, pi t. Well, first and foremost, we are asked to find the frequency of the current. That is, find that. Remember, the general equation for instantaneous current is given by I is equals to the peak current sine 2 pi frequency and time. If you compare these two equations here, we discover that that's a 2 pi frequency and the time is equal to the whole of this, 100 pi t. We make F the subject of formula, the frequency. I mean 100 pi t divided by 2 pi t. Let's get rid of this. You're left with 100 over 2. 100 over 2 will give you 50. So the frequency here is 50 Hz. That's for the first question solved. We're asked to find the peak value. The peak value. That's the next question. The peak value. If you compare this expression with this other expression, we discover this is the peak value of the current. That means the peak value is 30 ampere. That is 30 ampere. The last question that says we should find the root mean square value of the current. The root mean square value will be equal to the peak value divided by the square root of 2, divided by the square root of 2. This we can solve by substituting. The current here is 30 all over the square root of 2. If we divide that, that will give us, using a calculator, 21.2 ampere. 21.2 ampere. So class, we're able to see how we solve a problem using the instantaneous current given by sin t 100 pi t, where t is the time, and we're asked to find the frequency, the peak value of the current, the root mean square value of the current. We solve this situation and we obtain the value that we had. Thank you. The next class we're going to have will be on how to calculate or find the root mean square voltage. The root mean square voltage.